Hello everybody, welcome back. Let's continue on this thought. A question came up about this batteries, adding a second battery. Yeah? What's the result of that? What happens when you do something like that? And I said something like, well, suppose you took this neutral return wire, instead of returning it back to where it came from, you returned it to a different battery. Would that be okay? And it kind of depends on how you connect it. So the electrons are going to be looking for their way back to where they came from, right? Always want to go back home. So the electrons are going to be going through this battery and looking for their way out to go to the next battery. And then electrons would keep on going through that switch, through that light, back to this battery. Here's one thing to look for. If this is a 12-volt battery, that's how much pressure, how much power you could put out, how much voltage. And this is a 12-volt battery. You remember from first grade, I think my little granddaughter does that already. 12 plus 12 is 24 volts, right? So now we have 24 volts of power, but we have a 12-volt light bulb. This power is going to go to that light bulb and go like, bam, twice as much voltage as it's manufactured to handle. Because these voltages would add up. That make sense? So we can use this volume of power in a way that won't cause 24 volts to be applied to that light bulb by going back to where we were before. In other words, the neutral return returns back to where it is, but we take this other source and we hook it up in what we call parallel, and we take this 12 volts and we match it up with this 12 volts. You see that? And then this side of the battery gets matched to this side of the battery. So now what we've done is we've taken two 12-volt sources that are 12 volts in power, 12 volts in voltage, 12 volts in pressure, right? Only we have more acid in here, right? More capacity for this acid to burn longer and longer and longer. This is fuel for the fire, so to speak. And so this 12 volts is matched up with this 12 volts. It's really only 12 volts. It's not 12 plus 12 anymore. It's the same 12 volts, but a lot more quantity of sulfuric acid metal plates, and this will burn for twice as many hours. Let's say this was at 12, let's say this was going to burn for 100 hours. Now these two will burn for 200 hours at that rate. Okay, so that load matches that source. And we call this connection a parallel connection. Before we were talking about a series connection, which we wanted 24 volts. This is going to come into play very much when we get into solar electric power, because series circuits and parallel circuits, you have to know those like the back of your hand. And you will. So come back to us next time. We're going to continue with this, and I'll be doing some math. We're getting into a little bit of Ohm's law and make this even clearer and clearer for you all the time. Thanks.